All right, so today we'll be talking about Cilium identities and how we migrated between the different storage modes for them. In case you missed the first talks of the day, very quick summary, what Cilium identities are. So every workload running with Cilium is assigned a unique identity internally, and they're used for network policy enforcement. And a very quick example with pods. So the Cilium would use labels internally in order to generate the identity. So for this particular pod 1, it would generate some internal identity. For the pod 2 with different labels, so different identity. And then internally, when you write network policies, it will use these identities in order to allow or disallow traffic. But how are these identities stored? Because every agent needs to be able to retrieve these identities in order to make policy decisions. And there are two storage options. Historically, there was only one, so it was the key value storage for identities, most commonly etcd. And then the second option was added, which was to store identities as Kubernetes custom resources, so CRDs. So on the one hand, you have dedicated etcd store that you have to manage, but you are kind of putting less pressure on the API server and Kubernetes etcd. And on the other hand, you are storing the identities as CRD objects, so there's you don't have to maintain a separate etcd cluster, so the ops are a bit easier and there could be lower costs as well. But I actually don't have time to go into all the sort of performance implications for these two storage modes, but you can consult this interesting talk from last year from Marcel from Isovalent and Hemant, my former teammate. And just also a very quick example of what these identities actually look like. So on the left, you can see a very simple identity with some ID and the labels that are associated with it, which is stored in etcd. And on the right hand, you can see exactly the same identity, but stored as a Cilium identity Kubernetes resource. And I'm querying it with just simple kubectl command. And it's exactly the same identity on the left, on the right, just stored in a different backend. Why am I even talking about this? Just to give you some context. So historically at Datadog, we've been using the KVStore mode everywhere for identities because it was the only one available actually. But it became increasingly hard and expensive to operate hundreds of etcd clusters just for identities. They've also been pretty underutilized. And so we decided to just migrate to CRD mode. But how do we do that? At first, there was only one available option upstream, which was a very simple two-step migration process. So first, you would use this migrate identity tool to do just a point-in-time copy from the KVStore to CRD identities. And then once the copy is done, you switch the Cilium agents and the operator to read the CRD identities. However, there are some obvious issues with this approach. And the first one is that the identities end up being inconsistent, which could lead to traffic drops, for example. And this is because the copy is done sort of a point in time, and there is a gap between when you copy the data and when you actually migrate the agents in the operator, and so you would lose some identity changes in between. There's also no easy way to roll back this migration, no easy way to evaluate the performance impact on the control plane, and also it requires some additional tooling because you have to run this migrate identity command somewhere, make sure it succeeds and so on. So we kind of came back to square one. We wanted, trying to see what our migration requirements actually are. And the first one is, of course, that migration should be fully transparent to users. So we should have fully consistent identities. We should be able to quickly roll back if something bad happens. We should be able to easily assess the performance impact on the control plane before actually doing the migration. And finally, because we are an observability company, we need to have some very solid monitoring and alerting for this migration to make sure that it runs well. So all of this led us to introducing a new identity allocation mode to Cilium, which we contributed and which was officially released in Cilium 1.17. So it's called double write mode. It's a very simple, sort of straightforward database migration pattern mode. So the way it works is that in this particular example, you start with Cilium using KVStore for the identities. Then you enable this new double write mode. So it would write to both storage options, but will still read from the KVStore. Then you can follow the reads to CRD objects, but still keeping the KVStore in parallel. So making sure that all the identities are synchronized. And once everything runs smoothly, you can just cut the KVStore, and you end up with Cilium running in CRD mode with consistent identities. And just a quick note that at Datadog we did it in this particular direction, but nothing really prevents you from going the other way as well, if you need to. Now, in order to actually perform the migration in production, we needed to do some preparatory steps. The first one was to do some scalability testing for the control plane for the CRD mode. And this is where we decided to first start the migration on our smaller clusters, so meaning less than 1,000 nodes and with a lower pod churn. Then we also spent some time on analyzing the performance and cost impact of the migration. So more specifically, API server and etcd. We had to tune some API server configuration. And maybe the most interesting thing to note is that we had to tune the priority and fairness settings for the API server because the Cilium agents were putting way more load on the API server because they're using the CRD objects now. I also don't have time to go into this particular in APF, but tomorrow my coworkers Matteo and Ayaz are doing a talk about API priority and fairness, so you can attend it tomorrow at 11:15. We also did some rollback testing, so we had a cluster in KVStore mode, and then we migrated it to CRD, we decommissioned the etcd cluster, and then we recreated the cluster from scratch, and we migrated it back to KVStore mode just to make sure that we can easily go back if something bad happens. And finally, we set up some dashboards, logs, alerts, and so on. So here's a quick excerpt from our dashboard. You can see, I think it's the beginning of a migration to the double write mode, so from KVStore to the first double write mode. You can see the CRD identities being slowly populated to match the KVStore ones. And you can see the diff in red going to 0. So the identities are slowly getting in sync in this particular cluster. And finally, we actually did the migration in production. As I mentioned, we decided to start with smaller clusters first. We did some very simple automation with Python using internal Datadog tooling just to make sure that we can easily go through the 4 steps of the migration I showed before. Just because we had so many clusters to go through, doing it manually was a bit of a pain. We still required some manual validation for production clusters for some key moments of the migration because we're still doing a sort of a one-off migration for the some very sensitive systems, but I think we could have just written some monitor gates because now we're pretty confident migration it went very smoothly on a bunch of clusters. And finally, we decommissioned etcds once the migration proved to be successful. And just to sum it up, we successfully migrated more than 100 clusters to the CRD mode. We saw some significant cost reduction, and also the ops became easier with less etcd clusters to manage in our infrastructure. And maybe one sort of takeaway for you if you want to attempt this is that careful control plane tuning is required, and observability is key. So thank you very much.